Yeah, this is only a brief one. What it is, it's a look at the A-level equation associated with half-life. So it's connected to what you've already done at GCSE, but what you now need to do is be able to use natural logarithms to apply an equation. So we had a look at decay constant, we had a look at the number of nuclei last time, and we talked about the exponential decay curve and the shape of this graph. So if we've got an initial amount of nuclei, the time that it takes the amount of nuclei that are unstable to halve is the half-life there. So we find half of n0, we draw a horizontal line across, and then we go down. Now it's not enough now just to do that once, we have to do that 3 times to take an average. This is the proof to see if something follows exponential decay in any aspect, such as capacitance as another example. Okay, so if you are asked to prove if something is exponential or not, these 3 boxes need to be approximately the same width. Okay, so the other lesson, we had a look at this equation, which is the number of nuclei is equal to the initial number of nuclei multiplied by the exponential of the negative decay constant times by the time elapsed. Okay, now we can use this to derive an equation for half-life. So, half-life is how long it takes for half the number of nuclei to have decayed. So, we've got half the number of nuclei is equal to the initial number of nuclei times by the exponential of the negative decay constant times by the time elapsed, which in this case is the half-life. So let's cancel the 2 initial number of nuclei, that disappears. So we've got the natural logarithm of the half is equal to the negative decay constant times by the half-life. And we know that multiplying both sides by the natural logarithm removes the exponential because ln of e is equal to 1. Half is 2 to the minus 1. The natural logarithm of 2 to the minus 1 is the same as the negative natural logarithm of 2, okay, using maths laws. So, rearranging the equation, where we've got this identity is equal to this over here, to get rid of the negative, the equation for half-life is the natural logarithm of 2 divided by the decay constant. This will give you an answer in seconds, as in the unit in seconds, not that it takes seconds to do it. Thank you.